Right, so basically we'll be talking about the stock preparation here. Stock preparation in paper industry is the most important section. You can see here. And especially sometimes also called as the central section of the industry. You can see here basically we are adding all the chemicals and doing the mechanical treatments to the fibers for getting the required quality of the paper. So here. So it's showing here basically what are the different sections, like from the blending chest, the stock is coming, and the pulp slurry will be coming, and especially for movement of the slurry, it's required to have the consistency generally below 20%. So most of the time it's having the consistency in between 1% to nearby to maximum 20%. So it can be shifted or transported in the different pipelines with the help of the pump. And then we are taking to blending chest. From the name itself, it's clear it's a blending means we are mixing the different chemicals here, water and the fibers here. So we are adding the dilution water again, and then we can see here we are having the impeller like structure. It's a blade basically rotating at the high speed. So it will be mixing all the ingredients in proper fashion. And then with the help of the centrifugal pump, here this pump is a centrifugal pump. This pump will be lifting the stock here and then going here. And you can see here through the refiners, it's again sent to the thick stock is going to constant level box. So this is called as the constant level box or a stub box. And from here again it's circulated and given to the inlet of the another pump. That's called as the primary fan pump here. Right. So there are some important pumps here. So one is the primary fan pump, then secondary fan pump, and this will be basically circulating the stock through the refiners and centric cleaners, and then finally it's coming to the head box. So a head box will be feeding the raw material to the paper machine that will be forming the paper here. So a head box is the first equipment or a start of the paper machine section here. And you can see here it's once coming to the wire section, we are having the trays here, then water removal elements, drainage elements will be there. We are applying the vacuum again for removal of water. Finally, the weight paper sheet will be forming here, and then it's going to the press section. Right, and just below the paper machine, we are having the flat box, and it's called as the seal tank basically. So water will be coming with the help of the vacuum applied in the pipelines and then coming to a big tank that's called as the seal tank. Seal tank means basically a sealing arrangement will be there so that the vacuum will not be breaking. And again, just below the pooch roll, we are having the pooch pit. So whenever we are breaking the sheet here, some waste paper will be coming to the pooch pit. And then it is again recycled from here, so going to the saver. That means all the fiber and chemical will be saved here before sending to the effluent treatment plant here. So again, you can see here some other equipments are the meter valve. Then we are having the stub box here. So that will be supplying the material here by maintaining the constant level. So now the important point is what are the different important sections. One section is the machine chest, and this machine chest we already seen. This is the first tank basically. Chest means it's a large tank, that's why called as the chest. So this is the basically a storage tank before the paper machine, and it serves as the all the other tanks. Just like the mixing will be again taking place here, and will be maintaining the uniform concentration, or you can say the percentage of all the ingredients, whether it's a fiber, whether it's a chemical, different chemicals, dyes, basically mixing and maintaining the uniformity in the slurry. And it's having the concentration nearby to 3% to 5%, and that's why it's termed as the thick stock. The second important equipment here is the consistency control. Consistency, you know already. So basically the fiber percentage in given volume of the slurry. So generally we are measuring the consistency in the 100 ml of the pulp slurry. So if you are having, take for example, 5 gram fibers or solids are present here in the 100 ml, it is called as the 5% consistency. So if we are having the 10%, that means 10 gram fiber is present in 100 ml volume of the sludge. So it's a very important to measure the consistency. So we are doing the measurement online. That means in the pipeline itself, we can measure it and control it with the help of the addition of the dilution water. So generally we are adding the white water. That means the water which is being drained from the paper machine, it's having all the chemicals, but only the fibers will be in very small percentage, generally 0.1 or 0.05%. So basically it's water only having the some of the very fine particles of the chemicals being added here, having the slightly whitish color. That's why called as the white water. So we are adding the white water here and we are maintaining the consistency. So it's automatic basically with the computerized controls. Normally in industry we are having the DCS control, distributed computer are basically applied there, and with the help of the computer we can control the different parameters. So you don't have to do anything, it's already programmed, and we are putting the value, control this much, and it will be automatically controlling the solid percentage or consistency. Right. Another equipment that's very important is what is the tickler refining. It's or sometimes called the Jordan refiner. So again for mixing and giving the final touch to the fibers, so that there should not be any fiber bundle or flocks should not be there. Flocks means the grouping of the fibers. So large bundles of fibers will not be there. Otherwise, it will deteriorate the quality of the formation. The spreading of the fibers will not be there. So that's why we are passing through the Jordan refiners. So it will be mixing it and separating the fibers by breaking the fiber bundles or flocks. Then comes the stub box here. The stub box you can see in the diagram. Basically, it's maintaining the constant level. You can see here. If there the level is increasing, so it will from the sideline it will be going out. So constantly we are making the same level. So 3 feet level will be always maintained here, and then whatever is stock is going, so it won't be creating any fluctuation in the input pressure because the head is having the same value. So same pressure will be at the input line or input point of the pump, so won't be having any fluctuation in the input parameters and resulting into the same fixed flow rate, same pressure. So any fluctuation of flow rate or pressure will not be there. For that purpose, we are having the stop box. You can see the diagram here. Then another important is the basis weight meter and the valve. So you must be knowing we are having the different types of paper, having the different thickness and different weight, again the weightage per unit area. That means some paper are having the 60 gram weight for 1 meter square, it's called as the 60 GSM. Some paper are having the 80 gram per meter square, that's called as the 80 GSM. Similarly, some writing printing quality is having the 100 GSM, that means the 100 gram per meter square. Getting it? So depending on the different quality, different types of usage, we are having the different type of the GSM that can be controlled by the one important equipment that is called as the basis weight meter and the valve. Right, so basis weight meter or the valve is basically to maintain the GSM of the paper, grammage per unit area. It controls fiber feeding to the paper machine. So before going to the head box, it is passing through the basis weight meter and the valve here, and that will be controlling the GSM. So by changing the basis weight meter and valve, we can change the GSM. That means, for example, earlier we were making the 60 GSM newspaper for some newspaper company. Then we are trying to make the 75 GSM paper of the copier paper. So by increasing the opening in the basis weight valve, we can increase the basically the GSM GSM of the paper, right? So you can make the different GSM of the paper. Another important equipment is the basically the fan pump here in the approach flow system. So this fan pump is nothing but it is again the very large size centrifugal pump. Centrifugal pumps means it's having the impeller and casing system here. The impellers are rotating inside the large casing, and because of the high RPMs, the impellers are nothing but just like the fans. So because it's rotating the high RPMs, it will create a lot of the pressure and the kinetic energy, and that will be sent to the input of the machine here at the high pressure and the velocity here. So at that point, we can again dilute the thick stock by adding the white water or dilution water. And the fan pump is often used to mix these two streams. And after dilution with white water, the stock flowing towards the head box is at the consistency of generally 0.5 to 1%. So this is the important equipments here that's being used in the approach flow system. And generally again for cleaning purpose, for removal of the dirt, unwanted materials, metal scrap, we are having the cleaning and screening system, right? So after the fan pump, the stock is passing through one or more stage of the centric cleaners. So centric cleaners are nothing but hydroclones basically, just like the cyclones. We are having the hydroclones, which will be separating basically the solid particles, and the material is coming in the slurry form. Base is the hydro, water. That's why it's called as the hydroclones. That means the water is the base. Generally 95% will be water, and 5% are the different solids. In some solids, we are having the fibers, dirt particles, metal scrap, some unwanted material. So basically, we have to separate the wanted material and unwanted material, right? So unwanted is called as the debris. That means waste material, reject material. So final aim is to remove the debris material, and that may damage the paper machine and lower the paper quality. And because the cleaners impose a large head loss, a secondary fan pump is sometimes necessary between the cleaners and the screen to restore the pressure. That is the purpose, especially to make the pulp slurry more suitable for paper making. Right? So that is the point here. And sometimes we are again using the deculators. These are the devices especially to separate the air. Because you must be knowing while doing the mixing in any slurry, air is getting entrapped. Once the air is getting entrapped, air will create the bubbles basically, foam. And if you are creating a lot of the foam, it will deteriorate the quality of the formation of the paper. So foam should not be there, right? Foam or froth like a structure in the liquid. So must be knowing if we are having the some solid in the water base, having the slurry, and whenever we are passing through pipelines, mixing it, different equipments, a lot of the air will be entrapped. So once you are catching the air in the slurry, it will create a lot of the problems. One such problem is the pump cavitation. That means the pump will be failing, air will be trapped inside the casing and the impeller of the pump, and the pressure will be having a lot of the fluctuation, and failure of the pump will create a number of the problems. Getting it similarly, it may be having the problem while flowing inside the pipeline. It may be having the problem while applying the vacuum. It will break the vacuum here, and for that purpose, it's required to remove the air entrapped in the stock slurry. And for removal of the air, we are having the deculators, which will separate the air from the pulp slurry here. You can see the diagram here. So this is a diagram here. This you can see here we are applying the vacuum, so air will be separated here, and slurry by gravity it's moving here in the downward direction, and then going to the centric cleaners. These are the centric cleaners, conical centric cleaners called hydroclones, which will be separating the large size, high density particles, metal scrap, dirt, sand particles, and the except from the centric cleaners will be going to the further processing to the paper machine. Getting it? And then it's going to the flow distributor. Clear? So we'll stop here only, and next time we'll see the different more equipments here and how they are working.